Today, I want to talk about section 7.8, improper integers. This is like outline. The definition of an improper integral. I want to talk about two types of improper integers. The last one, I just show the how to solve an improper integral. The first one, what is an improper integral? The first one, we think about the fundamental theorem of calculus, part 2. So if the function f is continuous on the closed interval ab, then integral from a to b, f of x dx is capital F of b minus capital F of a. So what is capital F? The capital F is any antiderivative of f. So we call this is definite integral. This is definite integral. Definite integral. So we call proper integral. This is proper integral. Proper integral. Was it like one relation? Here, function f is continuous. So one more, the a and b are finite. So we call proper integral. Was it like an improper integral? We have two cases. Case one, the a is not a finite number. The a is like negative infinity. The b is not a finite number, like positive infinity. This is like one case. The second case is the function f is discontinuous. Discontinuous. We have two types of improper integral from the fundamental theorem of calculus. Case one, the a is the negative infinity. The b is negative infinity, the positive infinity. The integral from a to b f of x dx is improper. A is negative infinity or the b is positive infinity. We call improper integral. It's like a type 1, the infinite intervals. Infinite intervals. Second case, the function f is discontinuous at a, b, or c. The c is between a and b. Integral from a to b, f of x dx is improper. It's like a type 2. This is continuous integrand, right? The function f of x is discontinuous. This is second type of improper integral. The next one. So we have the two types of improper integrals like type 1 or type 2. So how can you calculate type 1 or type 2? The next one here. Type 1, infinite intervals. How to evaluate the improper integral of type 1? The type 1 is the infinite interval, infinite intervals. Suppose that integral from a to t f of x dx exists for every number t greater than or equal to a. How can you calculate integral from a to infinity f of x dx? Here, you can find integral from a to t f of x dx and take limit. The t is going to positive infinity, t is going to the positive infinity. Yes, we have this kind of result. What's like the main idea? You can change it to the definite integral from a to t, next to take the limit. So this is make sense? Yes, it makes sense. This meaning is exactly area under the curve from a to infinity. Was it like integral from a to t f of x dx? You choose t. So was it like integral a to t f of x dx area under the curve from a to t? What happens in limit? So you have to move t to right hand side, move to infinity. So move more, add this area, move more, add this area, move more, more like this. So exactly this many. So we have another terminology. Integral from a to infinity, f of x dx is conversion. What does it mean? The limit exists. You can define definite integral, take limit. The limit value is finite number. This is the answer is a finite number. We call conversion. The integral from a to infinity f of x dx is divergent. What does it mean? The limit does not exist. What's that? The find definite integral, take limit. This answer is infinity or negative infinity, or the limit is like oscillating. In this case, divergent. It's like a divergent. We have this kind of answers. Second type, suppose that integral t to b f of x dx exists. For every number t is less than or equal to b, how can you calculate integral from negative infinity to b f of x dx? Very similar. Only replace minus infinity by t. So like this. Next, take limit. T value approaches minus infinity. That's it. This is the whole idea. So like this. Was it like a graph? Similar. Was it integral from minus infinity to b, the whole area under the curve from negative infinity to b? How can you calculate? Find definite integral first from the t to b. Find this area first. The next, you can take limit. The t value approach to negative infinity. What does it mean? So this is t is moves more. What does it mean? Only add area more is going to the minus infinity. Exactly the area under the curve from negative infinity to b. Like this meaning, or like this. So similar. Improper integral from negative infinity to b f of x dx is conversion. What's that? The limit exists. The same. Find definite integral, take limit. This value is finite number. A finite number. The improper integral is conversion. The improper integral is divergent. What's that? Similar. Find definite integral. Next, take limit. Answer is infinity, minus infinity, or oscillating. Oscillating, in this case, is divergent. The divergent. So like this. The next one. Integral from minus infinity to infinity f of x dx. How can you calculate? Always split two improper integrals. Integral from negative infinity to a f of x dx plus integral from a to infinity f of x dx. Only split two intervals. Was it like a geometric meaning? So like this. So what's like exact geometric meaning of improper integral from minus infinity to positive infinity? You can find area under the curve from minus infinity to positive infinity. You can split two things. Find this area first. Next, find second area and add it. It's like the whole idea. So one more. The improper integral from minus infinity to positive infinity, f of x dx is conversion. What's that? The both improper integrals, integral from negative infinity to a f of x dx and integral from a to infinity f of x dx conversion. So what does it mean? So like this. So one more. What's it like a divergent? Either one is a divergent. Is a divergent. So my question. You can calculate this one by using two things here. So this is one example. So this is finite. This is finite. What is this improper integral? Conversion or diversion? Could you write your answer on the chatting board? What is your answer? The first improper integral has finite number. Second improper integral has finite number. What happens? This one, conversion or diversion? Okay. Okay. Okay, good. Yes, convergent. Because both are convergent. This is the reason. So one more. You can calculate this one. Answer is infinity, like divergent. This is like finite. What is the answer? Convergent or divergent? Yes, divergent. Here, either one is divergent, answer is divergent. Really be careful. Either one is divergent, answer is divergent. Either one is divergent, answer is divergent. You're right. The next tip, I'm going to give one example. Integral from 1 to infinity, 1 over x dx. Quadratic geometric meaning the next one. You can draw y equals to 1 over x from 1 to infinity. You can find area under the curve from 1 to infinity. So what's that? How can you calculate? So we can use this idea. Here, as I said before, only replace the infinity by t, is right? Just to choose t and cut. Find this area first. So like this. Next, take limit. T value approaches positive infinity. What does it mean? T is going to positive infinity. You can add more areas like this. So you can keep limit. T approaches infinity. Do you know what is integral 1 over x dx? Do you remember? So could you write your answer on the chatting board? What is integral 1 over x dx? Yep. Yep. It's good. So really be careful. The add number what? Absolute value of x from 1 to t. So like this. The next, you have to plug upper limit and lower limit. You plug upper limit t into here, so we have ln of absolute value of t minus ln of absolute value of 1. So like this. So in this case, t is going to positive infinity. You don't need absolute value sign. This is limit. T value approaches positive infinity. You don't need absolute value sign. Eliminate. T minus what is ln of 1? So could you run your answer? What's ln of 1? Okay. 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 Good. Answer is 0. So we have limit t approaches infinity ln of t. What's the like answer? You can draw graph of ln of t. This is like t is here. You can draw ln of t. Passing through 1. This is your x-intercept. So what's that? T value approaching infinity. The t value approaching infinity, the corresponding ln function is going up, going to the positive infinity. So what does it mean? The improper integral does not exist. It's right. Limit does not exist. Like infinity. What is the answer? The answer is integral from 1 to infinity. 1 over x dx is divergent. This is the answer. The divergent. That's right. This is the whole idea for solving this problem. like this, like this. The next, we think about one general form, integral from 1 to infinity, 1 over x to the power p dx. The case 1, p equals 1. Was it p equals 1? So from the previous example is right here. The previous example answer is divergent. So here p equals 1. Answer is diverges. The case 2, p is not equal to 1. How can you calculate p is not equal to 1? So you can use this idea. This is what? Same to integral from 1 to t, 1 over x to the power p dx, take limit. The t value approaches positive infinity. You can keep limit. This one. So what's that? Integral from 1 to t. You can change it to the negative exponent. So like this, you can use power rule. This is same to limit. The t value approaches positive infinity. The 1 over power negative p plus 1 x to the negative p plus 1 from 1 to t. So like this. So what's that? Limit t value approaching infinity. You can plug t, you can keep, it's like infinity. The 1 over negative p plus 1. You can plug t to the negative p plus 1. Minus, you can plug 1 into x. The 1 to negative p plus 1 is always 1. So we have this kind of things. The next, how can you calculate? So let me see. You can take a limit of this one. Is it convergent or divergent? So what do you think? So what do you think? So what is the limit? Going to finite number? What, infinity? So what do you think? So what is the answer? Do you know this limit? What is the answer? Divergent? 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 Depending on p value, you can change it to possibility. P is what? Greater than 1. We think about this case. P is greater than 1. That's right. So what does it mean? I'm going to give one example. So one example is P equals like 2. P is like 2. You can plug 2 into here. You can calculate limit. T value approaches positive infinity. So t to the negative, the p is 2. You can plug 2 into p, negative 2 plus 1. We have limit. T value approaches positive infinity, t to the minus 1. So what's that? Limit. T value approaches positive infinity. What is the answer? 1 over t. What is the answer? What is the answer? What's the limit of 1 over t? Yes, going to 0. You're right, going to 0. What equals p equals 3? You can choose another number p equals 3, similar. Limit. T value approaches infinity, t2. You plug 3 into here, p, negative 3 plus 1. T to the negative 3 plus 1. This is a limit. T approaches positive infinity, t to the negative 2. Limit. T value approaches positive infinity, 1 over t squared. We have 0. This is always 0. That's right. So what does it mean? What is the limit? We have one possible answer here. The t to the minus p plus 1 is going to 0. It's like going to 0. The remaining part is 1 over negative p plus 1 times minus 1. So exactly negative 1 over negative p plus 1, like a finite number. What's that? Conversion. So what's that? If p is greater than 1. P is greater than 1, conversion result. The second case, p is less than 1. P is less than 1. So what does it mean? I can choose p equal to 0. I can choose p equal to 0. We can calculate limit. The t value approaches positive infinity. So what's that? t to the plug 0 into p. Negative 0 plus 1 is only t to the 1. Right? T to the 1. What's the limit of t? What is the answer? The limit of t to the 1, t value approaches infinity is, what is the answer? Answer is, how about the other students? Yeah, answer is, yes, infinity. Was it like p equals minus 1, the less than 1? We can plug minus 1 into p. We can take limit t value approaches infinity, t to the negative 1 plus 1. So we have limit t value approaches positive infinity. So minus 1 times minus 1 is a positive 1. 1 plus 1 is 2. Exactly t squared. Going to what? Infinity. This answer is what? Always going to, this one is infinity. Infinity minus 1 is infinity. The negative p plus 1 is positive number. The positive number times infinity is infinity. What's that? Divergent. So if p is less than 1. So we can combine this the whole result. What kind of result do we have? We have two kind of result. What's that? Here. The improper integral 1 to infinity 1 over x to the p dx. We have two possible answers. Converges to this number, the negative 1 over negative p plus 1. The if p is greater than 1. Was it like p is equal to 1 or less than 1? Here, divergent and divergent. So we have divergent. So if p is less than or equal to 1, that's it. We have this conclusion. Right? It's like whole idea for solving this problem. So we have the same explanation, like this. Like this, combine, we have it. I'm gonna give the one example. The question is conversion or diversion. What's your answer? Conversion or diversion? What do you think? What's your answer? So this improper integral is conversion or diversion. What is your answer? Could you write your answer on the chatting board? Conversion? Conversion? Answer is conversion because I'm going to change the 1 to infinity like fraction form. We have the 1 over x to the 5 dx. You can check. This 5 is root of p. So p equals 5 exactly greater than 1. P is greater than 1. Answer is conversion. That's it. This is answer. What is this one? This one. Conversion or diversion? Conversion or diversion? What's your answer? Answer is divergent because from 1 to infinity, 1 over x to the power 1 over 2 dx. What's p? P is 1 over 2. The p is 1 over 2. The 1 over 2 is less than or equal to 1. Exactly here, always divergent. So it is divergent. This is answer, right? That's the whole idea for solving this problem. One more. Only replace 5. What's answer? Answer doesn't change. 5 doesn't change. So what does it mean? I can change this 1 by A. The A is any positive number. You can use any positive number A. We have same result. It doesn't matter. Only replace the lower limit by any positive number. We have same answer. We have the same answer. So like exactly the one good result from section 7.8. The next tip. So evaluate negative infinity to positive infinity 1 over 1 plus x squared. Is right? So what does it mean? So this is top one is positive infinity, bottom is like negative infinity. Was like idea? You can change it to the minus infinity to a 1 over 1 plus x squared dx plus integral from a to infinity 1 over 1 plus x squared dx. You can split these two improper integrals. This is idea. So what's like a? Any real number. What is your choice of a? Could you choose a? What is a? Your choice. What's a? 0? 0? Is right? What's your choice? Could you write your answer on the chatting board? What is your choice? 0? 0, 0? The 0? Okay, 0. And 0. Yeah, it doesn't matter. You can choose 0, 1, 2, negative 1, 10, 100, minus 100. It doesn't matter. You can choose any real number. What is easiest number? So what's easiest number for calculation? 0 is best choice. It doesn't matter any number, but 0 is best choice. I'm going to use 0. I'm going to use 0 is better. It's the best choice. You can choose 0, like this. So how can you calculate this one? On the integral from, you can replace minus infinity by t. 0, 1 over 1 plus x squared dx. Take limit. In this case, t value approaches minus infinity. Plus, second one, integral from 0 to replace infinity by t, 1 over 1 plus x squared dx. Take limit. T value approaches positive infinity. You can calculate limit t approaches minus infinity. You can calculate integral 1 over 1 plus x squared dx. What is integral 1 over 1 plus x squared dx? Could you run your answer on the chatting board? What's integral 1 over 1 plus x squared? Okay. So could you write answer on the chatting board, please? Yeah, 1 over a, arctangent, inverse tangent, arctangent, inverse tangent, all things good, you're right. In this case, a is 1, a is 1, so we have only arctangent, inverse tangent. Inverse tangent of x from t to 0, plus limit. T value approaches positive infinity, same thing. Inverse tangent of x from 0 to t. The first one, the limit, t value approaches minus infinity. You can plug 0 first. The first one, inverse tangent of 0 minus inverse tangent of t plus limit. T value approaches positive infinity. You can plug upper limit first, the inverse tangent of t minus inverse tangent of 0. like this. How can you calculate inverse tangent of 0? Inverse tangent of 0 is unknown angle theta. So you can use definition of inverse tangent, only interchange 0 and theta. So we have 0 equals tangent theta. What's angle theta? The satisfying the set 0 equals tangent theta. What is theta? Could you run your answer on the chatting board? 0 equals tangent theta. What kind of angle has this result? 0 equals tangent theta. Okay. Yep. Angle is 0. So this is what? Going to 0. This is going to 0. So we have it. Next, what is it like a graph of inverse tangent of t? Because I want to calculate limit values. So like this, you can draw inverse tangent of t. We need two horizontal asymptotes. This is pi of 2. One more asymptote, negative pi of 2. Negative pi of 2. So inverse tangent function is like this. Like this. So first one, t value approaches minus infinity. The t value approaches minus infinity. So here, t value approaches minus infinity. What's the corresponding inverse tangent function? This graph is inverse tangent. Inverse tangent function approach to this horizontal asymptote, negative pi of 2. So we have kim negative and negative pi of 2. Plus, second one, t value approach infinity. Here, t value approach infinity. What happens? Inverse tangent. The t value approaches positive infinity. The corresponding graph approach to pi of 2. So we have pi of 2. So negative 1 times negative 1 is positive pi of 2 plus pi of 2. The final answer is pi. So what does it mean? We have this result. Integral from negative infinity to infinity. 1 over 1 plus x squared dx is conversion. Is conversion to number pi. So that's it. This is final answer of this question. Final answer of this question. The next tip. This is like explanation, like this. The second type, this continuous integrand. So what does it mean? How can you evaluate an improper integral of type 2? What's a type 2? The function f is discontinuous. The first one, suppose that function f is discontinuous at b. So how can you calculate this one? So we think about one idea. The graph is like this. From a to the b, the function is discontinuous at b. We have like a vertical asymptote. Graph is from here to here, like going up. So like this, is right? The function f is discontinuous at b. How can you calculate? Like this. One idea. You can only choose t value between a and b. Find this area first. From a to t, f of x dx. So how can you find the exact area under the curve from a to b? The idea is very simple. The t value approaches p from the left. So you have to move t, add more area. T more, add area. T is going to b. This is idea. Limit. The t value approaches b from the left. Right? From the left. This is like idea. Solving this problem like this. So improper integral is conversion. What does it mean? Limit exists. Same. Calculate definite integral. Take limit. Value is finite. What does it mean? Conversion. The conversion. Second one. Improper integral is divergent if the limit does not exist. What does it mean? You calculate definite integral, take limit, limit value is infinity, minus infinity, or oscillating. So divergent. It's like improper integral is divergent. Second case. Suppose that function f is discontinuous at a. How can you calculate the similar one? Only difference is here. The function f is discontinuous at a. So graph is like this. This one, the infinite discontinuity, like this from A to B. How can you calculate? Similar. You can choose t values here, find this area. This area is integral from t to b. F of x dx. Next, you have to move t to a from the right. So what does it mean? So you can add more area, move more, add more area, and so on. Take limit. The t value approaches a from the right. So like this. So this one, the improper integral is convergent. What does it mean? The limit exists the same. You can calculate definite integral, take limit. This is always finite. It's like exact meaning. Was it like a divergent? If the limit does not exist, the calculate definite integral, take limit, answer is infinity, minus infinity, or oscillating. The improper integral is the divergent. The next tip, how can you calculate the improper integral from a to b f of x dx if function f is discontinuous at c, where c is between a and b? So how can you calculate the next one? We have one point c is here. We have discontinuous. It's like a, and like this. This is like b. You can find the area like this. How can you do that? You can split two improper integral from a to c, f of x dx, plus integral c to b, f of x dx. So that's it. This is the whole idea for solving this problem, like this. So improper integral is convergent if both improper integral from a to c f of x dx and integral from c to b f of x dx are convergent. The improper integral is divergent. What does it mean? If either one is divergent. That's it. The simple example is this is finite. This is finite. What's the answer? Improper integral is convergent because both are convergent. But here, this is finite. This one is divergent, so like infinity, minus infinity, or oscillating, so like this. So one out of two improper integrals is divergent. What is the answer? This whole improper integral is always divergent because either one is divergent. It's like a good idea for checking the improper integral is convergent or divergent. The next tip. So we are going to this example. How can you calculate the integral from 1 to 4? 1 to 4, 1 over square root of x minus 1 dx. How can you calculate? Integral from 1 to 4, 1 over square root of x minus 1 dx. Let me see. Was it like a given interval? Given interval is 1 to 4. The first, you can check. The function f of x is integrand 1 over square root of x minus 1. So f of x equals 1 over square root of x minus 1 is continuous on this interval or not? The continuous or not? What do you think? The continuous or not? Is it not continuous? The what is the number? The which number? The at which number is f discontinuous? Yes, 1. You can plug 1 into x. We have 1 over square root of 1 minus 1. It's like 1 over 0 is undefined. Undefined. So what does it mean? The function f is discontinuous. Discontinuous at 1. At 1. So how can you solve this improper integral? The always integral from only replace the discontinuous point by t. For take limit. Take limit. The t value approaches 1 from the left, from the right. How can you decide? Here. We have given interval 1 to 4. The 1 is discontinuous point. It's like discontinuous point. You can choose t. The t value approaches to discontinuous point from the right. Exactly 1 from the right. You can decide it like this. So how can you calculate? How can you find integral 1 over root x minus 1? Do you have any idea? Do you have any method for solving this problem? What kind of method? Okay, use up is right. Use up. You can use up is right. What's u? Yes, inner function x minus 1. You're right. What's du? du is x minus 1 prime. dx. So we have the du equals only dx. You can write this function is g of x. So what's that? Keep limit. T value approaches 1 from the right. Integral 1 over the x minus 1 is just u. Square root of u. dx is only du. So you have to change lower limit, upper limit by using relation of u and g of x. What does it mean? G of t, g of 4. So this is same to limit. The t value approaches 1 from the right, integral. What's like g of t? You plug t into x. We have t minus 1. What's like g of 4? You plug 4 into x. The 4 minus 1 is only 3. This one is the u to the negative 1 half. The du change to the power form. We have limit. T value approaches 1 from the right. So we have antiderivative 1 over power minus 1 over 2 plus 1 u to the negative 1 over 2 plus 1 from t minus 1 to 3. So this is Kim limit. The t value approaches 1 from the right. The 1 over minus 1 plus 1 is 1 over 1 over 2. This one is 1 over 1 over 2. Just flip, only 2. 2. U to the minus 1 half plus 1 is u to the positive 1 half. Change to the square root of u. The 2 square root of u from t minus 1 and 3. You can plug limit. T value approaches 1 from the right. You can plug 3 first. You can plug t minus 1 later. 2 times the square root of t minus 1, like this. Next, take limit. T value approaches 1 from the right. You plug 1 into t. 1 minus 1 is going to 0. The remaining part is 2 root 3. 2 root 3 is finite number. A finite number. So what does it mean? The improper integral 1 to 4. 1 over the square root of x minus 1 dx is conversion. Conversion to root 3. So that's it. This is the whole idea for solving this problem. So like this. That's good. The all procedure is here. So we have it. This one, like this. One more. This is like the last part. We think about a comparison test for improper integrals. As like a comparison theorem, suppose that function f and function g are continuous functions with g of x is between 0 and f of x. One more assumption, x is greater than or equal to a. If integral a to infinity f of x dx is a conversion, what happens to g of x? In integral from a to infinity g of x dx is also a conversion. Second one, if integral from a to infinity g of x dx is a conversion, what's like a conclusion? Integral from a to infinity f of x dx is divergent. So this is like a true or not. This is like true. We can use this graph. What does it mean? We think about a first. What's like the first one a? We can use this one. 0, g of x, and f of x. You can take integral each side, a to infinity dx, a to infinity dx, a to infinity dx. Inequality doesn't change. What's that? Integral 0 is always 0. What's integral f of x? This assumption, conversion. What does it mean? Finite. But what happens? Middle one is between 0 and finite. What's a possibility? Only finite. Yes, conversion. That's it. This is like A. What's like B? Similar. This is like we have 0, g of x, and f of x are given. Same. You can take integral from a to infinity dx, integral a to infinity dx, integral a to infinity dx. So what's it like assumption? Integral g of x is divergent. What is the possibility? Infinity minus infinity oscillating. This is one possibility, three possibilities. So minus infinity is impossible because only positive function has a positive integral. So oscillating impossible because always positive, take integral like increasing. So only one possibility, infinity. Improper integral of g of x dx is infinity. What happens to bigger one? Bigger one is only one possibility, infinity. That's it. Integral f of x dx is divergent. That's it. This is all proof of a comparison theorem. So we can try. This improper integral is convergent. How can you prove? How can you prove this one? So this is like the best way. You can just split. You can split two improper integral, two integrals. One is definite integral from 0 to 1, e to the minus x squared dx, plus integral 1 to infinity, e to the minus x squared dx. One more. This is always a convergence, right? This is exactly finite number. You don't need to calculate. This is like a finite number because the integrand is continuous function. 0 to 1 is a finite interval. The integral is always finite. You don't need it. Only think about here. This is a divergent. This whole thing is divergent. This is a convergent. This whole thing is a convergent. Depending on this one. Integral from 1 to infinity, e to the minus x squared. So how can you calculate? So we think about so far from here, what's x value? Just greater than 0. greater than or equal to 1, when you think about only this domain, you can compare x and x squared. X is greater than y equal to 1. Which one is bigger? So which one is bigger? X and x squared. Which one is bigger? In this domain, x is greater than y equal to 1. X squared. Which one is bigger? Could you run your answer on the chatting board? X squared is bigger. X squared is bigger. Is right? So what does it mean? X is linear function. X squared is parabola. So this is x squared. Intersection point is 1. X is greater than 1. X squared is greater than x. Yes, we have it. Next, take a negative sign. What happens? Here, negative x squared change. Is right? So we have this result from here. The minus x squared is less than y equal to negative x. For x is greater than y equal to 1. The next, you can take e. Take e to both sides. What's inequality? Inequality is same direction, what change it? So what's your answer? Same direction, what change it? What's that? What direction? Same direction? Change it. So change it. You can take e, doesn't change it. What's it like exponential function? Exponential function is this one. It's like exponential function e to the t. You can choose 2 points, negative x minus x squared in here. So we have this one, negative x squared. This one is negative x. You can plug into here. This value is e to the negative x squared. Minus x is bigger. You can plug into graph. This one is e to the minus x. Yes, inequality doesn't change it because e to the t is increasing function. This is like a reason. Doesn't change. The same direction. So we have it. So next, e to the minus x squared. E to the minus x. This is bigger. You can take integral from 1 to infinity to both sides. 1 to infinity to both sides. Inequality doesn't change. But this case is a little bit easier. A little bit easier than previous one. How can you calculate integral 1 to infinity e to the minus x dx? Here, integral 1 to replace infinity by t, e to the minus x dx. Take limit. T value approaches positive infinity. So what's that? Take limit. T value approaches infinity. What's that? This one is antiderivative integral e to the minus x. What is integral e to the minus x? Do you know that? What is integral e to the minus x? Could you write your answer on the chatting board? What is integral e to the minus x? For my question, was it like integral e to the minus x dx? What's that? Yes, negative e to the minus x plus x, right? We have e to the negative e to the minus x from 1 to t. So this is same to limit t approaches infinity. You can plug t into x, negative e to the minus t, negative e to the minus 1. Like this. So we have limit. T value approaches infinity. The negative, you can change it to the positive exponent. The negative times negative 1 is positive 1. E to the minus 1 is 1 over e. Here, t value approaching infinity was e to the t. Here, t value approaching infinity, exponential function is going to positive infinity. 1 over infinity is 0. Answer is 1 over e. What's that? Conversion. So this is what? 1 over e. We have it. So what's like a conclusion? Conclusion is integral 1 to infinity e to the minus x squared dx is less than y equal 1 over e. So this one is smaller than finite number. This is like your finite number. I don't know exact number. We know this kind of things. This is also finite number. So what does it mean? Yes, this one is convergent. So we think about here. This is what? Finite convergent. You can add two things. So this one is exactly finite number plus finite number, also finite number. So what's the answer? Improper integral is convergent by using comparison theorem. Comparison theorem. It's like a whole idea for solving this problem. Like this, right? Okay, so this is like all for today lecture, the section, the 7.8. Tomorrow, Kasha covered section 11.1, sequence. So this is like a today lecture. That's it. If you have any trouble, any question, please write your question on the chatting board. If you don't have any question, you can leave this live session. So thank you for attending my class. I really appreciate that you attend my class. So really thank you. Yeah, thank you. So you're welcome. You're welcome. Okay, you're welcome. So yeah, you don't have any question, you can leave a live session. Any question, could you write your question on the chatting board? I will answer your question. Oh, was it like a purpose? It's like a good question. So let me see. So why do you compare this one with the integral e to the minus x? Because do you know this one? How can you calculate? You know this one? Impossible. Impossible. So we cannot calculate integral e to the minus x squared. So in this case, only replace complicated one with simple one, find exact integral and compare. The smaller one is less than y equal. This one we have answered. Yeah, the 10:30 session is only today. So I will upload today lecture section 6.8, the indeterminate form, the L'Hopital's rule, the on canvas around 10:30 or 11 p.m. You can find my lecture video. The today 10:30 the a.m. class. Yeah, this is like the last one. Yeah. Okay, do you have more question? Could you write your question on the chatting board? I will answer your question. So if you don't have any question, you can leave live session. You're welcome. You're welcome. You're welcome. Okay.